Scientists are warning. The big one isn't just a possibility, it's an inevitability. It's not a matter of if, but when. Seismologists, geologists, and emergency planners all agree. A massive earthquake is long overdue, and the consequences could be catastrophic. Cities could crumble, entire regions could be left in ruins, and millions of lives could be at risk. But just how soon could it strike? And more importantly, are we ready? The devastation of a megaquake. Imagine waking up to the ground beneath you shaking violently. Buildings sway, roads crack open, bridges collapse, and entire neighborhoods are swallowed in dust and debris. Power grids fail, gas lines rupture, and fires ignite in the chaos. Communications are cut off, and emergency services are overwhelmed within minutes. This isn't a scene from a Hollywood disaster movie. This is what scientists predict will happen when the big one finally strikes. Major cities like Los Angeles, San Francisco, Seattle, Tokyo, Jakarta, and Istanbul sit on some of the most dangerous fault lines in the world. In the United States alone, the San Andreas Fault and the Cascadia Subduction Zone pose the greatest threat. A megaquake of magnitude 8.0 or higher would devastate these regions, causing hundreds of billions of dollars in damages and potentially displacing millions of people. But what if the destruction isn't limited to just one area? What if a chain reaction of seismic activity triggers quakes worldwide? Are we overdue for the big one? For decades, experts have been trying to answer one burning question. Are we overdue for a megaquake? Some fault lines have been eerily quiet for far too long. The last massive rupture of the Cascadia Subduction Zone happened in the year 1700, over 320 years ago, and scientists believe it's building pressure for another catastrophic event. The San Andreas Fault, which has produced devastating earthquakes in the past, has been locked in place, accumulating stress that could be released in a sudden, explosive movement at any time. New research suggests that the recurrence intervals for major earthquakes in these regions suggest we are entering a period of heightened seismic activity. Some scientists believe that a major event is likely within our lifetime, perhaps even within the next few decades. The unsettling part: no one knows exactly when or where it will strike. Can we predict when it will happen? If a megaquake is inevitable, can we predict when it will hit? This is one of the biggest challenges in modern seismology. While experts can track fault movements, measure stress buildup, and analyze seismic patterns, earthquakes remain notoriously difficult to predict. Some warning signs, like foreshocks, GPS plate movement, and even unusual animal behavior, have been observed before major earthquakes, but there is no foolproof method to pinpoint an exact date or time. However, new technology is emerging. AI-and machine learning are revolutionizing earthquake prediction by analyzing massive datasets and identifying patterns that humans might miss. Early warning systems, like those used in Japan and Mexico, can provide a few crucial seconds of advance notice before a quake strikes, giving people just enough time to seek shelter. But will that be enough when the big one finally arrives? Why this matters to everyone this isn't just about California or the Pacific Northwest. Other high-risk zones around the world, including the Himalayan region, the Philippines, Iran, Turkey, and Chile, are also sitting on ticking time bombs. The next megaquake could happen anywhere, and the consequences could be global. Massive seismic events don't just cause physical destruction, they can trigger economic collapse, food shortages, and even geopolitical instability. The truth is, we are woefully unprepared for a disaster of this magnitude. Many buildings in earthquake-prone cities are still not reinforced. Emergency response plans are outdated. Millions of people live in high-risk zones without any idea of what to do when the shaking starts. The question isn't just whether we are overdue for the big one, the real question is, are we ready for what's coming? The warning signs are there. Scientists have been sounding the alarm for years. The big one is closer than we think. The only question that remains is whether we will listen before it's too late. What is the big one? Seismologists have long warned of an inevitable megaquake, a seismic event so powerful that it could reshape entire landscapes and devastate cities within minutes. When experts talk about the big one, they are referring to a massive earthquake, typically magnitude 8.0 or higher, that is expected to strike a major fault line that has been building pressure for centuries. Unlike smaller, more frequent earthquakes that release stress in short bursts, the big one is the result of a long overdue rupture, unleashing stored energy in one catastrophic event. This term is often associated with the San Andreas Fault in California, but it applies to other high-risk fault lines worldwide. The Cascadia Subduction Zone in the Pacific Northwest, the North Anatolian Fault in Turkey, and the Japan Trench are all capable of producing a megaquake with destructive force. The defining characteristic of the big one is its ability to cause widespread devastation, triggering secondary disasters like tsunamis, fires, and infrastructure collapse. It is not just another earthquake, it is an event that will redefine history. The historical context of megaquake. To understand why the big one is inevitable, we need to look at past seismic events and the fault lines that pose the greatest threat today. The San Andreas Fault, stretching over 800 miles through California, is one of the most well-known fault lines in the world. It marks the boundary between the Pacific and North American tectonic plates, two enormous slabs of Earth's crust that are constantly moving. The last major rupture on the southern section of the San Andreas Fault occurred in 1857, with an estimated magnitude of 7.9, but experts believe that this section of the fault is overdue for another major quake. Further north, the Cascadia Subduction Zone is a ticking time bomb. This 600-mile fault off the Pacific coast runs from northern California to British Columbia. The last time this fault ruptured was in the year 1700, causing an estimated magnitude 9.0 earthquake that sent a massive tsunami across the Pacific Ocean, even reaching Japan. Geological evidence suggests that Cascadia produces a megaquake every 300 to 500 years, meaning that the next one could happen at any moment. When it does, scientists predict an event on par with the devastating 2011 Japan earthquake and tsunami. Other regions have their own seismic threats. The North Anatolian Fault in Turkey has produced a series of powerful earthquakes, creeping steadily toward Istanbul, a city of over 15 million people. In Japan, the Nankai Trough is expected to unleash a massive subduction zone earthquake that could bring widespread destruction to densely populated coastal cities. Around the world, experts agree, megaquakes are not a question of possibility, but inevitability. How powerful could the big one be? Magnitude determines the energy release of an earthquake, and the big one is expected to register above magnitude 8.0, potentially reaching 9.0 or higher. A magnitude 8.0 earthquake releases energy equivalent to over 6 million tons of TNT, while a 9.0 earthquake releases 32 times more energy than an 8.0, an unimaginable force. The strongest earthquake ever recorded was the 1960 Chile earthquake, which reached magnitude 9.5, causing tsunamis that traveled thousands of miles. The 2004 Indian Ocean earthquake, which measured magnitude 9.1, generated a tsunami that killed over 230,000 people across 14 countries. The 2011 Japan earthquake reached magnitude 9.1, resulting in a devastating tsunami that triggered the Fukushima nuclear disaster and caused over $235 billion in damages, the costliest disaster in history. Scientists predict that if the big one occurs on the San Andreas Fault, it will likely reach between magnitude 7.8 and 8.2, enough to flatten Los Angeles and disrupt California's economy for years. If it happens on the Cascadia Subduction Zone, the magnitude could exceed 9.0, producing the largest earthquake in US history and a deadly tsunami that could inundate entire coastal towns within minutes. These are not theoretical scenarios, these are scientifically modeled outcomes based on historical data and modern simulations. Why this megaquake will be unlike any other earthquakes happen all the time, but the big one will be different from the smaller tremors that people experience regularly. Smaller earthquakes, even those as strong as magnitude 6.0 or 7.0, typically last only a few seconds to a minute. The big one, however, could cause violent shaking for up to 5 minutes or more, an eternity in seismic terms. Unlike regular quakes that affect a localized area, the big one will be regional, meaning its impact will span hundreds of miles. Cities far from the epicenter will still experience destructive shaking, with aftershocks potentially continuing for months or even years. Infrastructure damage won't just be limited to collapsed buildings. It will sever transportation networks, shut down power grids, and trigger massive fires from ruptured gas lines. Another key difference is the domino effect that the big one could set off. A megaquake on the Cascadia Subduction Zone could destabilize the San Andreas Fault, leading to multiple catastrophic quakes within days or weeks. Seismologists have observed earthquake clustering, where one major quake increases stress on nearby faults, setting off a chain reaction of seismic activity. This means that one disaster could trigger another, creating an unprecedented seismic crisis. The warning signs are already present. Scientists continue to detect strain buildup along major fault lines, and recent smaller earthquakes in high-risk areas indicate increasing seismic activity. The Earth is constantly shifting, and at some point, the stress that has been accumulating for centuries will be released. The question is no longer if the big one will strike, it is only a matter of when. The science of megaquakes the Earth's surface may feel solid beneath our feet, but it is constantly shifting. Our planet's crust is made up of massive sections called tectonic plates, which float on top of the molten mantle below. These plates are always in motion, though the movement is so slow, just a few inches per year, that it goes unnoticed. However, when stress builds up along fault lines, the result can be sudden, violent, and catastrophic. The energy released during an earthquake is a force so powerful that it can level cities, trigger tsunamis, and even alter the rotation of the Earth itself. How earthquakes work. Most earthquakes occur along plate boundaries, where tectonic plates grind against one another, get stuck, and eventually snap free in a violent rupture. There are three main types of faults where earthquakes originate: strike-slip faults, thrust faults, and subduction zones. The San Andreas Fault in California is a strike-slip fault, meaning the two plates slide horizontally past one another. The Cascadia Subduction Zone, on the other hand, is a megathrust fault, where one plate is being forced under another. These subduction zones are responsible for the largest and most destructive earthquakes in history. When stress accumulates over decades or centuries, an eventual rupture sends seismic waves through the Earth, shaking the ground above. The magnitude of an earthquake, measured on the moment magnitude scale, MW, determines its strength. A magnitude 7.0 earthquake is already destructive, but when an earthquake reaches magnitude 8.0, 9.0, or beyond, the energy release is exponentially greater. What makes some earthquakes catastrophic? Not all earthquakes cause devastation. Some happen deep underground, dissipating energy before it reaches the surface. Others occur in unpopulated areas where they cause little damage. However, three key factors determine whether an earthquake will become a true catastrophe: depth, location, and secondary disasters. Shallow earthquakes, occurring less than 70 kilometers beneath the surface, are the most dangerous. These quakes release their energy directly into populated areas, amplifying their destructive power. The location of the quake is also crucial. When an earthquake strikes near a major city, the devastation can be immense. The 2010 Haiti earthquake, for example, was magnitude 7.0, which is relatively small compared to some megaquakes, but it struck near Port-au-Prince, a densely populated area with poorly built infrastructure, resulting in over 230,000 deaths. The most devastating earthquakes don't just shake the ground, they trigger secondary disasters. Tsunamis, landslides, fires, and liquefaction can multiply the destruction. Subduction zone earthquakes, in particular, often trigger massive tsunamis capable of traveling thousands of miles across the ocean. The shaking itself is deadly, but the walls of water that follow can be even more devastating, wiping out coastal cities within minutes. Examples of past megaquakes. Some earthquakes have been so powerful that they changed the way scientists understand seismic activity. The most extreme examples in modern history provide a chilling glimpse into what could happen when the big one finally strikes. The 2011 Japan earthquake, known as the Tohoku earthquake, measured magnitude 9.1 and struck off the coast of Japan, generating a 130-foot tsunami that devastated entire towns and killed nearly 20,000 people. This earthquake was so powerful that it shifted the Earth's axis by 10 centimeters and even shortened the length of a day by a fraction of a second. The 2004 Indian Ocean earthquake, also a magnitude 9.1, ruptured along the Sumatra-Andaman subduction zone, triggering one of the deadliest tsunamis in history. The wave, traveling as fast as a jet plane, struck Indonesia, Thailand, Sri Lanka, India, and several African nations, killing over 230,000 people. The energy released by this earthquake was equivalent to 23,000 Hiroshima atomic bombs. The 1960 Chile earthquake holds the record as the strongest earthquake ever recorded, with a magnitude of 9.5. This event triggered a tsunami that traveled across the Pacific Ocean, reaching as far as Hawaii and Japan. The destruction was immense, displacing 2 million people in Chile alone and causing landslides, flooding, and fires that took thousands of lives. These earthquakes are some of the most extreme in history, but they are not unique. They follow a pattern, one that suggests the big one is inevitable. How the big one compares to past megaquake. If the big one occurs along the San Andreas Fault, scientists predict it will likely measure between magnitude 7.8 and 8.2, a devastating event but not quite on the scale of a 9.0 plus subduction zone earthquake. However, what makes the San Andreas Fault particularly dangerous is the proximity to major cities like Los Angeles and San Francisco. The dense population, aging infrastructure, and potential for massive aftershocks could make this earthquake one of the most destructive in modern US history. If the big one strikes the Cascadia Subduction Zone, the magnitude could exceed 9.0, making it comparable to the 2011 Japan earthquake or the 2004 Indian Ocean disaster. The biggest concern with this type of earthquake is the tsunami threat. Coastal cities in Oregon, Washington, and British Columbia could be wiped out within 15 to 30 minutes of the initial shaking. Unlike Japan, which has strict building codes and tsunami defenses, much of the Pacific Northwest is unprepared for an event of this scale. Another terrifying possibility is a sequence of megaquakes occurring in rapid succession. If a Cascadia rupture triggers movement along the San Andreas Fault, the result could be multiple high-magnitude earthquakes within days or even hours. This would create a national emergency unlike anything the US has ever faced, with disruptions to transportation, water supply, and power grids on an unprecedented scale. The big one is not an exaggeration or a fear-driven myth. It is a scientifically recognized inevitability. Every data model, every recurrence interval, and every past megaquake tells the same story: it will happen. The only question is whether we will be ready when it does. Are we overdue? The alarming evidence. The question of whether the big one is overdue is one that haunts seismologists, emergency planners, and millions of people living in earthquake-prone regions. Earthquakes do not follow human timelines. They do not operate on a fixed schedule, yet science has given us the ability to analyze patterns, study fault line movements, and understand recurrence intervals. The unsettling reality is that many of the most dangerous fault lines in the world have remained locked for centuries, building pressure that could be released in an instant. When looking at historical trends, seismic models, and recent geological data, the evidence overwhelmingly suggests that we are entering a period of increased seismic risk. Understanding earthquake recurrence intervals. Earthquakes are cyclical events. They occur when the stress along a fault line surpasses the strength of the rocks holding it together. The time between major earthquakes on a given fault is known as its recurrence interval. Some faults release energy frequently, producing moderate quakes every few decades. Others remain silent for centuries, accumulating immense stress before rupturing in a single catastrophic event. The San Andreas Fault, one of the most studied fault lines in the world, has an estimated recurrence interval of roughly 150 to 200 years for a major earthquake. The Cascadia Subduction Zone, which runs along the Pacific Northwest, has an even longer recurrence interval, with massive earthquakes striking every 300 to 500 years. Based on these estimates, both of these faults are now well beyond the typical rupture windows. Scientists warn that they could give way at any time, and when they do, the San Andreas Fault, overdue by more than a century. The southern section of the San Andreas Fault has been locked in place for more than 300 years. The last major rupture occurred in 1857, producing a magnitude 7.9 earthquake that tore through California. Since then, stress has continued to build. Given its recurrence interval, many scientists argue that this fault is overdue for another major quake by at least 100 years. The northern section, closer to the San Francisco Bay Area, last ruptured in 1906 during the San Francisco earthquake, which registered a magnitude 7.9 and caused massive destruction, killing over 3,000 people. The central section of the fault has experienced smaller quakes that relieve some of the stress, but the southern portion, stretching from Palm Springs to Los Angeles, remains locked and primed for an enormous release of energy. Computer models show that when the San Andreas finally gives way, it could produce a magnitude 7.8 or higher earthquake, causing ground shaking that could last for over 2 minutes. Los Angeles and San Diego, home to more than 20 million people combined, would be hit hardest. Freeways could collapse, power grids could fail, and water pipelines running through the fault zone could be severed, leaving millions without essential services for weeks or even months. The troubling aspect of the San Andreas Fault is that scientists know a major rupture is inevitable, but they cannot say exactly when it will happen. The longer it remains locked, the more energy it stores. Some geologists fear that when it finally breaks, the quake could be stronger than anything California has experienced in recorded history. The Cascadia Subduction Zone, a megaquake 320 years in the making. While the San Andreas Fault is concerning, the Cascadia Subduction Zone presents an even more terrifying scenario. This 600-mile-long fault lies off the coast of Northern California, Oregon, Washington, and British Columbia. It is a megathrust fault, where the Wanda-Fuka plate is slowly sliding under the North American plate. The last time this fault ruptured was in the year 1700, producing an estimated magnitude 9.0 earthquake that generated a tsunami powerful enough to reach Japan. Unlike the San Andreas, which produces primarily ground shaking, the Cascadia Subduction Zone has the potential to generate a massive tsunami. Geological evidence, including buried coastal forests and sediment deposits, confirms that Cascadia has produced megaquakes approximately every 300 to 500 years. At over 320 years since its last rupture, scientists agree that this fault is entering its danger zone. If Cascadia breaks, the shaking could last for up to 5 minutes, and the tsunami it produces could send a 100-foot wall of water crashing into the coastline. Cities like Portland, Seattle, and Vancouver would experience violent shaking, while coastal towns like Eureka, Crescent City, and Cannon Beach could be completely wiped out. The Pacific Northwest is far less prepared for such an event than California. Many buildings in Oregon and Washington are not reinforced for seismic activity, and tsunami evacuation plans are woefully inadequate. Scientists warn that when this rupture occurs, it will be one of the most catastrophic disasters in US history. FEMA estimates suggest that 13,000 people could die, with another 27,000 injured and over 1 million displaced. Unlike the San Andreas, which mostly impacts California, the Cascadia event would be a regional disaster affecting multiple states and Canada. New alarming seismic studies and recent discoveries. In recent years, seismic activity has been increasing along major fault lines, leading some geologists to believe that a major event could be imminent. In California, GPS data has shown that the San Andreas Fault is slowly creeping, indicating that stress is continuing to build. In the Pacific Northwest, recent discoveries of silent earthquakes, or slow slip events, suggest that stress is shifting deep within the Cascadia Subduction Zone. These slow-moving quakes, which occur over weeks or months, could be precursors to a major rupture. New seismic imaging has also revealed that portions of the Cascadia Fault are weaker than previously thought, meaning that when it does rupture, it could break even more violently than expected. Scientists have also detected strange seismic waves, low-frequency tremors that have never been seen before, originating from deep within the fault. These discoveries suggest that the region may be undergoing a process of stress reorganization, a warning sign that a major earthquake is coming. Debunking the myths. Why overdue doesn't always mean imminent. Despite the clear evidence that these faults are at risk, some experts caution against panic. The term overdue can be misleading because earthquake recurrence intervals are estimates, not exact predictions. Just because a fault has reached its historical average does not guarantee that an earthquake will happen tomorrow. Some faults remain locked for hundreds of years longer than expected, while others rupture sooner than anticipated. However, being overdue means that the conditions for a major earthquake are fully present. The longer a fault remains locked, the greater the stress buildup, and the more powerful the eventual rupture will be. When an earthquake does occur, the damage will be far worse if communities are not prepared. The biggest misconception is that because the big one hasn't happened yet, it won't happen anytime soon. This kind of thinking is dangerous. The absence of a major earthquake in the last century does not mean we are safe, it means we are living in borrowed time. Scientists have done their part by providing the data. The responsibility now lies with governments, engineers, and individuals to prepare for the inevitable. The evidence is overwhelming. The San Andreas Fault is locked and overdue. The Cascadia Subduction Zone has entered its historical danger window. Modern technology is detecting anomalies that suggest seismic stress is increasing. Whether it happens in 10 years or tomorrow, the big one is not a myth or speculation, it is a scientific certainty. The real question is, when the ground finally gives way, will we be ready? The devastating impact of a megaquake. The day the big one strikes will begin like any other. People will be going about their daily routines, driving to work, sitting in classrooms, shopping in crowded stores. Then, without warning, the ground will begin to shake violently. In just a few seconds, the world will descend into chaos. Buildings will crumble, roads will split apart, and power lines will snap, plunging entire regions into darkness. The destruction will be unlike anything modern society has ever experienced. Scientists predict that when the big one hits, its impact will be swift, brutal, and long-lasting. What happens when the big one hits? The moment the fault line ruptures, seismic waves will begin radiating outward, sending violent tremors across hundreds of miles. The intensity of the shaking will depend on the magnitude of the quake, but if it registers magnitude 8.0 or higher, it could shake the ground for 2 to 5 minutes straight. That may not sound like a long time, but in an earthquake, every second matters. The longer the shaking continues, the more structures will fail. In cities built on soft soil or reclaimed land, the damage will be even worse due to soil liquefaction, where solid ground temporarily turns into a thick, unstable slurry, causing buildings to sink or topple. Coastal cities like San Francisco, Los Angeles, and Seattle are particularly vulnerable to this phenomenon. In the worst-case scenario, entire neighborhoods could collapse as the ground beneath them gives way. The destruction won't be limited to buildings. Bridges and highways will crumble, leaving survivors trapped in isolated pockets of devastation. Gas lines will rupture, igniting massive fires that will rage uncontrolled as emergency crews struggle to reach affected areas. Water mains and power grids will fail, leaving millions without electricity, clean drinking water, or basic sanitation. Hospitals will be overwhelmed with casualties, while first responders will be stretched to their limits trying to pull people from the wreckage. Tsunami risks. Will coastal cities be wiped out? If the big one originates from a subduction zone, such as the Cascadia Subduction Zone or the Japan Trench, the earthquake itself will be only the beginning. Within minutes of the initial rupture, an enormous section of the ocean floor will be displaced, triggering a tsunami that could reach heights of 100 feet or more. Coastal cities will have only 15 to 30 minutes to evacuate before the first waves come crashing ashore. The impact of a tsunami is swift and merciless. Unlike normal ocean waves, tsunami waves do not crest and break. Instead, they arrive as a rapidly rising wall of water, sweeping away everything in their path. Entire towns could be erased from the map in a matter of minutes. The 2011 Japan earthquake demonstrated just how devastating a tsunami can be, with entire communities flattened and over 20,000 lives lost. In the Pacific Northwest, cities like Seaside, Oregon, and Crescent City, California, would likely be completely submerged. Even major urban centers like Seattle and Vancouver could experience catastrophic flooding, with seawater surging miles inland. For people unable to evacuate in time, the tsunami will be nearly impossible to survive. Aftershocks and secondary disasters. Even after the initial earthquake and tsunami, the danger will not be over. In the hours and days that follow, Powerful aftershocks will continue to strike, some of them measuring magnitude 7.0 or higher. These aftershocks will bring down already weakened buildings and trigger additional landslides, further complicating rescue efforts. Massive fires will break out across affected cities, fueled by ruptured gas lines and collapsed electrical grids. In past earthquakes, such as the 1906 San Francisco earthquake, fires actually caused more destruction than the quake itself. Without functioning fire hydrants or emergency response teams, these fires could spread unchecked, consuming everything in their path. Economic collapse is another inevitable consequence. The 1994 Northridge earthquake, which was magnitude 6.7, caused $44 billion in damages in California alone. A magnitude 8.0 or 9.0 earthquake could result in losses exceeding $200 billion, making it one of the costliest disasters in history. Thousands of businesses would shut down, supply chains would be disrupted, and insurance companies could go bankrupt under the weight of claims. The financial toll could take decades to recover from, with global markets feeling the ripple effects. Which cities are most at risk? Some of the world's largest and most densely populated cities sit on or near major fault lines, making them particularly vulnerable to a megaquake. In the United States, Los Angeles and San Francisco are at extreme risk due to their proximity to the San Andreas Fault. A major rupture could cause entire sections of these cities to collapse, with millions of residents left homeless. Seattle faces an even greater threat due to the Cascadia Subduction Zone. A magnitude 9.0 earthquake in this region could flatten the city and trigger a tsunami that would wipe out coastal towns in minutes. Portland, Vancouver, and other Pacific Northwest cities would suffer similar devastation, with major portions of their infrastructure destroyed beyond repair. Beyond North America, other cities are equally at risk. Tokyo, Japan, sits on a seismic hotbed, with multiple tectonic plates colliding beneath it. The Tokyo-Yokohama region is home to over 38 million people, making it one of the most vulnerable urban areas in the world. A megaquake could lead to tens of thousands of casualties and hundreds of billions of dollars in damages. Jakarta, Indonesia, also sits on a dangerous subduction zone, with a history of devastating earthquakes and tsunamis. The city's poor infrastructure and high population density make it especially vulnerable to a high-magnitude quake. Istanbul, Turkey, faces a similar threat, as it lies near the North Anatolian Fault, a fault system that has been creeping steadily closer to the city over the past century. Seismologists predict that a magnitude 7.5 or higher earthquake is inevitable in the near future. Realistic death tolls and damage estimates. Estimating the death toll of a future earthquake is difficult, but historical data gives us a grim idea of what to expect. The 2004 Indian Ocean earthquake and tsunami killed over 230,000 people. The 2010 Haiti earthquake, despite being only magnitude 7.0, killed over 230,000 people due to poor infrastructure. If the big one strikes California, estimates suggest that over 10,000 people could die, with hundreds of thousands injured. In the Pacific Northwest, a Cascadia megaquake and tsunami could kill more than 13,000 people, with over 1 million displaced. In Tokyo, the Great Kanto earthquake of 1923 killed 140,000 people. A modern equivalent could result in even higher casualties due to the city's increased population. The economic toll will be staggering. A San Andreas rupture could cause over $200 billion in damages, while a Cascadia event could exceed $300 billion. If Tokyo or Jakarta were to experience a magnitude 9.0 earthquake, the financial losses could reach $500 billion, devastating global trade and sending shockwaves through international markets. Beyond the immediate casualties and financial losses, the long-term consequences will be felt for years, if not decades. Cities will struggle to rebuild, economies will falter, and survivors will be left to pick up the pieces of a world that was forever changed in just a matter of minutes. The big one isn't just a natural disaster, it is an event that will redefine history. The terrifying reality is that for some regions, the countdown has already begun. The question is not if, but when. The only thing left to determine is how prepared we will be when it finally arrives. Can we predict the big one? Earthquakes are among the most unpredictable natural disasters, striking without warning and leaving devastation in their wake. Despite decades of research, scientists have yet to develop a reliable method to predict exactly when and where a major earthquake will occur. Unlike hurricanes, which can be tracked days in advance, or tornadoes, which are preceded by distinct weather patterns, earthquakes give little to no warning. This unpredictability is what makes the big one so terrifying. Seismologists rely on historical data, fault line activity, and plate movements to estimate when a region is due for a major earthquake, but these methods are far from precise. Some fault lines experience small tremors regularly, while others remain locked for centuries before suddenly rupturing. This inconsistency makes it difficult to forecast when an earthquake will strike. Scientists can calculate probabilities. For instance, the U.S. Geological Survey estimates that there is a 99% chance of a magnitude 6.7 or higher earthquake hitting California within the next 30 years. But these probabilities offer little guidance for day-to-day preparedness. Even though long-term prediction remains elusive, researchers have made progress in identifying short-term warning signs that could provide seconds to minutes of advance notice. These warning signs, while not foolproof, offer a glimpse into how future technology might improve earthquake forecasting. Warning signs. Can nature predict an earthquake? Throughout history, there have been reports of unusual animal behavior preceding major earthquakes. In ancient China, observers noticed that snakes emerged from their burrows in the middle of winter, only to freeze in the cold air. Before the 1975 Haicheng earthquake, which measured magnitude 7.3, officials evacuated thousands of people based on reports of restless animals, including dogs barking incessantly and cows refusing to enter barns. While this case is often cited as a rare example of a successful earthquake prediction, most scientists remain skeptical about using animal behavior as a forecasting tool. Other potential warning signs include small foreshocks, tiny earthquakes that sometimes precede a major rupture. Before the 2011 Japan earthquake, scientists detected an unusual cluster of foreshocks near the epicenter. However, foreshocks do not always lead to a major quake, and many large earthquakes occur with no foreshocks at all, making this an unreliable warning method. GPS technology has revealed that tectonic plates sometimes move in slow, imperceptible ways before a major rupture. These slow movements, known as slow slip events, have been detected along the Cascadia Subduction Zone. Some scientists believe that these events may indicate increasing stress on the fault, potentially serving as a precursor to the big one. However, the connection between slow slip events and major earthquakes is still being studied, and no conclusive pattern has emerged. New technology for earthquake detection. Despite the challenges in predicting earthquakes, advances in technology are providing new hope for early detection. Artificial intelligence and machine learning are revolutionizing seismic data analysis, allowing researchers to detect subtle patterns that humans might miss. By analyzing vast amounts of seismic activity in real time, AI systems can recognize anomalies that may indicate an impending earthquake. One promising development is the use of underground fiber optic cables as seismic sensors. Researchers have discovered that existing internet cables can be repurposed to detect seismic waves, essentially turning entire cities into earthquake detection networks. These systems could provide an additional layer of early warning, especially in urban areas where traditional seismic sensors may not be widely distributed. Another emerging technology is deep earth scanning, which uses high-energy waves to create a 3D image of fault lines beneath the surface. This technique has revealed previously unknown weaknesses in the Cascadia Subduction Zone, suggesting that certain areas may be more vulnerable than previously thought. As this technology improves, it may allow scientists to identify which sections of a fault are most likely to rupture, providing more accurate early warning systems. How much time would we really get? While predicting earthquakes days or weeks in advance remains impossible, early warning systems can provide seconds to minutes of advance notice once an earthquake has already begun. These systems work by detecting the initial seismic waves, known as P waves, which travel faster than the destructive S waves that cause the most damage. Japan and Mexico have some of the most advanced early warning systems in the world. Japan's JALERT system uses a nationwide network of seismic sensors to detect large earthquakes and immediately send alerts via smartphones, television, and radio. In Mexico, the SASMEX system has saved countless lives by giving residents up to 60 seconds of warning before the arrival of strong shaking. The United States is developing its own early warning system, known as Shake Alert. Currently active in California, Oregon, and Washington, Shake Alert sends alerts to smartphones, businesses, and infrastructure systems, allowing people to take cover and automated systems to shut down gas lines or halt trains. However, the effectiveness of these systems depends on distance from the epicenter. Those closest to the fault will receive little to no warning, while those farther away could get 30 to 90 seconds of notice. While a minute of warning may not seem like much, it can be enough to prevent mass casualties. People can move to safer areas, doctors can stop surgeries, and power plants can shut down critical systems. Studies show that just 10 seconds of warning can reduce injuries by up to 50%, making early detection one of the most critical advancements in earthquake preparedness. The limits of prediction. Can we ever know the exact date? Despite the progress made in earthquake science, the reality is that we are still a long way from being able to predict the big one with absolute certainty. Unlike hurricanes or volcanic eruptions, earthquakes do not provide clear warning signs. Every fault line behaves differently, and stress can build up over centuries before suddenly releasing without any noticeable precursors. Some scientists believe that quantum computing and advanced AI models may one day allow for more accurate earthquake forecasting. Others argue that earthquakes are fundamentally chaotic events that may never be predictable in the way that we hope. The best approach for now is preparedness rather than prediction. Instead of waiting for the perfect warning system, cities must invest in earthquake-resistant infrastructure, emergency response planning, and public awareness campaigns. Scientists may never be able to tell us the exact date when the big one will strike, but we already know that it will happen. The real question is whether we will be ready when it does. Earthquake preparedness. Are we ready? When the big one strikes, survival will depend not just on luck, but on how well individuals, cities, and governments have prepared for the inevitable. A disaster of this magnitude requires more than just immediate response efforts. It demands long-term planning, reinforced infrastructure, and a society-wide commitment to preparedness. Despite the warnings from seismologists, many regions remain underprepared for an earthquake of catastrophic scale. The question is, when the shaking starts, will we be ready? Government preparedness. Are we truly prepared for a megaquake? Governments play a crucial role in disaster response and mitigation. Agencies like FEMA, Federal Emergency Management Agency, in the United States, along with state and local emergency management offices, have been tasked with developing strategies to handle large-scale seismic disasters. Their plans involve early warning systems, coordinated rescue operations, and infrastructure reinforcement, but the reality is that even the most well-prepared agencies struggle in the face of true megaquakes. The Shake Alert early warning system in California, Oregon, and Washington is one example of government intervention, but its effectiveness depends on how well the public is educated on earthquake response procedures. Emergency drills, evacuation plans, and public awareness campaigns are critical, but many people remain unaware of what to do when an earthquake strikes. Studies have shown that in regions with high earthquake risks, a large percentage of residents have never participated in a formal earthquake drill, which significantly reduces their chances of reacting appropriately when disaster strikes. Funding for seismic retrofitting is another challenge. Governments at the federal and state levels provide limited financial assistance for strengthening infrastructure, but many at-risk communities lack the resources to upgrade their homes and public buildings. While some cities have invested in reinforcing bridges, overpasses, and emergency shelters, others have done little to address the seismic vulnerabilities of older structures. Without large-scale investment in preparedness, even the most well-designed emergency response plans may fall apart in the chaos of a real megaquake. A major city's earthquake-proof. The resilience of a city during a megaquake depends heavily on the quality of its infrastructure. In earthquake-prone regions like California, Japan, and Chile, building codes have evolved to incorporate seismic safety features, requiring reinforced concrete, shock-absorbing foundations, and flexible steel frames that can withstand violent shaking. However, not all buildings meet these modern safety standards. In cities like San Francisco and Los Angeles, older structures, including historic buildings, homes built before 1980, and aging apartment complexes, pose a significant risk. Many of these structures were built before strict seismic codes were implemented, making them highly susceptible to collapse during prolonged shaking. While some cities have enacted mandatory retrofitting laws, requiring vulnerable buildings to be reinforced, compliance remains low due to the high costs of upgrades. Seattle, Portland, and other cities in the Pacific Northwest face an even greater challenge. Unlike California, where frequent earthquakes have prompted better building codes, the Pacific Northwest has not experienced a major earthquake in over 300 years. As a result, thousands of buildings were not designed with earthquakes in mind, making them even more vulnerable in the event of a magnitude 9.0 quake from the Cascadia Subduction Zone. Other major cities around the world are also at risk. Jakarta, Istanbul, and Mexico City all sit in seismically active zones but have poorly enforced building regulations, meaning millions of residents live in structures that could collapse instantly during a megaquake. Even in Tokyo, which has some of the world's most advanced earthquake-resistant buildings, densely packed urban areas still pose a significant risk of mass casualties from falling debris and fires. While modern skyscrapers in wealthy nations are engineered to sway rather than break, it is the millions of smaller, older buildings that pose the greatest threat. Unless large-scale retrofitting projects are completed, the next megaquake could turn entire neighborhoods into piles of rubble. Personal preparedness: how to survive the big one. Survival during an earthquake is not just about government action, it is about individual preparedness. Every second counts when the ground starts shaking, and knowing what to do can mean the difference between life and death. Having an earthquake emergency kit is a fundamental step. Experts recommend keeping at least 3 days' worth of food, water, and medical supplies in case rescue teams cannot reach certain areas immediately. A fully stocked earthquake kit should include a flashlight, extra batteries, a first aid kit, personal identification, cash, a whistle for signaling, and necessary medications. Those living in high-risk areas should also secure sturdy shoes and gloves to navigate through debris if needed. During an earthquake, the immediate instinct for many people is to run outside, but this is one of the most dangerous reactions. The safest strategy is to drop, cover, and hold on. Moving during violent shaking increases the risk of being injured by falling objects. Experts advise getting under a sturdy table or desk, protecting the head and neck, and staying indoors until the shaking stops. If outside, people should move away from buildings, power lines, and anything that could collapse. If driving, they should pull over safely and avoid stopping under bridges or overpasses. After the initial quake, aftershocks, some of them strong enough to cause additional damage, can continue for days, weeks, or even months. People should be prepared for ongoing disruptions to power, water, and communication networks. Checking on neighbors, especially the elderly or those with disabilities, can make a critical difference in saving lives. Evacuation strategies and tsunami risk. For those living in coastal regions, evacuation planning is crucial, especially in the event of a subduction zone earthquake that triggers a tsunami. The 2011 Japan earthquake showed just how quickly a tsunami can wipe out entire cities, leaving little time for people to react. If a tsunami warning is issued, there may be as little as 15 to 30 minutes before the first wave arrives. Coastal residents should already have evacuation routes planned and know where the nearest high ground is located. Vertical evacuation in reinforced buildings is a last resort, but in some cases, it may be the only option. For those in urban centers, understanding escape routes and emergency shelters is equally important. In the immediate aftermath of a major quake, roads may be completely impassable, making car-based evacuation impossible. Having an emergency meeting point with family members and knowing alternative routes on foot can be life-saving. Cities need to invest in better emergency signage, well-marked escape routes, and public drills to ensure people know what to do when disaster strikes. In Japan, where earthquake and tsunami drills are a regular part of life, survival rates have improved due to well-practiced evacuation strategies. Other nations must follow this model if they hope to minimize loss of life in a megaquake scenario. Are we truly ready? Despite all the research, warnings, and technological advancements, the truth is that most cities are not fully prepared for the big one. Government agencies may have emergency plans in place, but without proper funding, enforcement of building codes, and widespread public awareness, the human and economic toll will be catastrophic. Individuals who take preparedness seriously stand a far better chance of surviving. Having an emergency kit, knowing how to react during an earthquake, and planning for evacuation in the case of tsunamis or fires can make a life or death difference. However, large-scale resilience requires collective action. Governments must prioritize infrastructure safety, enforce strict building codes, and ensure communities are educated about the dangers of megaquakes. The world may not be able to predict the exact moment the big one will strike, but we already know it is coming. How prepared we are will determine whether it becomes one of the worst disasters in human history, or a test that humanity successfully overcomes. Controversial insights. Is the government hiding something? For years, conspiracy theories have circulated about whether governments and elite insiders have been warned about the big one but are keeping the information hidden from the public. Some believe that key officials already have data suggesting a high likelihood of an imminent megaquake, yet they choose not to disclose this information to prevent widespread panic and economic turmoil. The idea that seismic data and classified reports exist but are not shared with the general population is not as far-fetched as it may seem. Did officials already warn insiders? One of the most persistent theories is that government agencies and elite corporate entities have been quietly preparing for a megaquake behind the scenes. Some point to the sudden relocation of corporate headquarters, massive insurance policy shifts, and unusual financial transactions as possible indicators that those in power know more than they let on. One widely discussed case involved reports that a major tech company quietly relocated key infrastructure out of California, citing seismic risk concerns. Real estate insiders have observed that certain high-profile executives have sold properties in high-risk zones, moving their assets to more stable locations. Some have suggested that these moves were based on classified briefings given to select corporate and government leaders, urging them to protect their investments before a major quake strikes. In 2019, FEMA conducted a large-scale emergency preparedness drill known as Cascadia Rising, designed to simulate the aftermath of a massive earthquake along the Cascadia Subduction Zone. While the event was officially described as a routine disaster preparedness exercise, some believe it was triggered by new, undisclosed seismic data suggesting that a major event was imminent. Similar drills have been conducted in California, raising questions about whether these agencies expect the big one to hit much sooner than they publicly admit. The lack of transparency surrounding classified government earthquake reports has only fueled further suspicion. Some seismologists have hinted at internal research that paints a far more alarming picture than what is publicly disclosed. While most official statements insist that the big one could happen within decades, leaked reports suggest that certain fault lines are under significantly more strain than initially believed, meaning a rupture could happen within years or even months. Why is there no national megaquake plan? One of the biggest concerns is that there is no comprehensive national plan in place for a megaquake. While local and state agencies have preparedness initiatives, there is no cohesive, large-scale strategy to deal with a disaster of this magnitude. Hurricanes, floods, and wildfires all have well-funded national emergency response plans, but when it comes to earthquakes, the response appears fragmented and underfunded. Even though scientists have warned for decades about the inevitability of a massive quake, large-scale federal preparedness efforts remain shockingly inadequate. A true megaquake will not just impact one city or state, it will have ripple effects across the entire country. Supply chains will be disrupted, fuel shortages will occur, and financial markets will experience a major shock. Despite this, there is no clear federal action plan on how to deal with the economic and infrastructural fallout. Some critics believe this is because governments are afraid of triggering mass panic and economic instability by openly admitting just how bad the situation could get. California and the Pacific Northwest, two of the regions most at risk, have insufficient emergency housing plans, outdated evacuation strategies, and underfunded retrofitting programs. If the big one strikes, millions could be left without food, water, or medical assistance, yet the government has no large-scale contingency plan for how to house or care for these displaced individuals. Many skeptics argue that the lack of urgency is not due to ignorance but deliberate negligence. Preparing for a megaquake at the national level would require trillions of dollars in infrastructure investments, something that government officials and corporations may not want to commit to until disaster is imminent. Could the big one trigger an economic collapse? A megaquake wouldn't just be a natural disaster, it could also trigger a financial meltdown. The 2011 Japan earthquake and tsunami resulted in over $235 billion in damages, making it the costliest disaster in history. A magnitude 9.0 earthquake in California, the Pacific Northwest, or Tokyo could far exceed that amount, crippling industries, disrupting trade, and sending global markets into freefall. The real estate market in seismic zones could collapse overnight. If San Francisco, Los Angeles, or Seattle suffered catastrophic damage, millions of people would be forced to abandon their homes, triggering mass foreclosures. The insurance industry would be overwhelmed with claims, and some analysts believe that major insurance companies could go bankrupt trying to cover the losses. The tech industry, heavily concentrated in California, could also suffer a major economic shock. If Silicon Valley were to sustain significant damage, billions in intellectual property, cloud computing servers, and research facilities could be lost. Supply chains would be disrupted, leading to delays in electronics manufacturing, automotive production, and other key industries. If a Cascadia megaquake and tsunami were to strike, West Coast ports would be out of commission for months or even years. The ports of Seattle, Portland, and Los Angeles handle over 40% of US imports, meaning a prolonged shutdown would create massive supply chain disruptions, leading to shortages in food, electronics, and consumer goods across the country. Are we underestimating the true scale of devastation? The public's perception of earthquake risk is often based on past disasters, but the big one is likely to be far worse than anything in modern history. The 1906 San Francisco earthquake is often cited as an example of what could happen, but in reality, today's urban centers are larger, more complex, and more vulnerable. The global population has increased dramatically in the past century, with megacities housing tens of millions of people in earthquake-prone zones. A catastrophic quake today would not just result in infrastructure damage, it could lead to mass casualties on an unprecedented scale. Experts warn that casualty estimates for the big one are often too conservative. Government agencies frequently cite numbers in the tens of thousands, but if a magnitude 9.0 quake were to hit a heavily populated area, the death toll could exceed 100,000. If a tsunami were to strike a coastal city, hundreds of thousands could be at risk, especially if evacuation orders are delayed or ineffective. In the immediate aftermath of a megaquake, the medical system would collapse. Hospitals would be overwhelmed, emergency response teams would be stretched thin, and shortages of medicine, food, and clean water would create a secondary humanitarian crisis. The social impact would be just as severe. Looting, civil unrest, and mass migration away from affected areas could destabilize entire regions. Some geologists have also raised concerns about the possibility of cascading seismic events, where one major earthquake triggers additional quakes along nearby fault lines. If a Cascadia Subduction Zone rupture were to put stress on the San Andreas Fault, the result could be back-to-back disasters within days or weeks. Despite these risks, many people remain unaware or dismissive of the true scale of destruction the big one could bring. Some experts believe this is due to government reluctance to provide full disclosure, as acknowledging the full scope of the threat would demand immediate and costly action. The evidence is clear, the big one is coming. Whether governments, corporations, and individuals choose to acknowledge the severity of the situation remains to be seen. But when the ground starts shaking, denial will no longer be an option. Despite all the uncertainty surrounding the exact timing, there is no uncertainty about what must be done. Governments, businesses, and individuals must take preparedness seriously. Seismic retrofitting, early warning systems, and emergency response plans can save lives. Personal preparedness, having an emergency kit, knowing evacuation routes, and practicing safety drills, can mean the difference between survival and tragedy. The big one will happen. No one knows if it will be tomorrow, next year, or decades from now. But when it does, the only question that will matter is whether we were ready.